All right. Hello, everybody. I'm Shane Jarrell. I'm Controls and Automation focal point for Deepwater Gulf of Mexico assets, specifically Perdido. We're in charge of day-to-day run and maintain aspect of production facilities in Deepwater Gulf of Mexico. Perdido, the facility I support, is about 200 miles south of Galveston, Texas, and floats in about 8,000 feet of water. So, pretty remote, pretty interesting and challenging environment. Um, we recently went through an effort to try and bring our uh, functional safety system into the new century. Um, we digitalized it. I'm sorry I didn't get digital transformation somewhere in the slide pack. I didn't realize that was mandatory until today. Uh, but it's in the spirit of digital transformation. So our case for change, in the design phase of a project, we start off with a HAZOP where we identify unmitigated consequences that the process can present. Um, this typically is owned and run by tech safety or process safety, and its own software. You go through this effort of defining every consequence and what the potential risk is. If the severity is high enough, we would go to do a LOPA or layer of protection analysis. Typically, it's in another software and is owned partially by process safety and controls, where we analyze the strength of our barriers that are in place and whether it is acceptable or a LARP to protect against the unmitigated consequences defined by the HAZOP. Once we define our barriers, we look at the safety instrumented system to see which strength or sill level of our safety system we need. That would go to a third software, and in Shell, that would be SIFPro, where we calculate the strength of the barrier based off of initiating event frequencies, probability of failure on demand, all those good things, and come up with a calculated sill level. We go back to the LOPA to make sure that the sill level that we're able to achieve with the instrumentation in place is adequate to satisfy the requirement of LOPA. Once you move into operations, what we need to do is make sure that our barriers remain intact and strong enough. This is where we see the breakdown currently. We test our safety devices at prescriptive and calculated intervals. The results of those tests don't necessarily get fed back into the machine to tell us that our safety system is performing at the level that we're expecting or requiring it to be. So what we did with partnering with SLM, we used their software tool, which has the LOPA, HAZOP, and SIL validation all in one software. So we have one system, one source of truth. One of the issues during the design phase is that if the process changes or the design changes, you move a pump upstream or downstream of a piece of equipment, you add a valve, you add a line somewhere, that could potentially change the demand scenarios and frequencies of your system. In order to capture that, you would have to go back, adjust your HAZOP, potentially adjust the LOPA, and it could affect the required SIL levels. In this SLM software, those are all linked. So any changes that happen in the design phase or as a result of the SIL validation gets captured in the other sections automatically. What we did in our Perdido instance was bring in safety layer information from the process control system. So from Pi, we can bring in demand events from the safety system and bypass status. So the strength of your safety layer is calculated based on a given demand frequency and your testing intervals and your mean time to repair. If you are putting your devices in bypass significant more times than is designed, then you're weakening the strength of your barrier. And the same with the demands. If you're placing demands on the system more frequently than you designed, then that's deteriorating the strength of your barriers. We also have a system called SMART, where we report to regulatory the results of our testing. So we can bring in, it's manually at this point, but we can bring in the results of our testing, whether it's pass or fail, and keep track of those with the SLM tool. And where the testing intervals are not required or prescribed by regulatory, we can actually look at the success of those tests and extend the testing frequencies and still maintain the given SIL level. So using the integrated modules, like I was saying before, they have a revision history. So anytime we make changes, it would capture. Uh, when you pull up a safety instrumented function or protective layer, it'll show you the associated scenarios that it's being used to protect, and it'll also show you the cause and consequence of the scenarios that you're protecting. And again, this is if you change your SIF design, it'll reflect back to the LOPA, or if you change your HAZOP or LOPA requirements, it'll cascade to your IPLs. So a lot of historically the LOPA analysis has been done qualitatively with a general assumption of a SIL 1 as an order of magnitude reduction, or a PSV as a certain order of magnitude, and you would look at your barriers and determine, kind of, does this feel right? Do we think we're protected enough? What we're doing with the SLM software is actually calculating those risks and finding out what our risk reduction factor is for a given SIF, and not just taking orders of magnitude credit for it. So they give you a graphical representation of the trip function and the risk reduction factor. The good thing with the software is you can customize your failure rate data or statistics and run it based off of industry standard, Shell standard, or proven in use. So you can look at the different strengths that you're able to get using different metrics. Another good feature is the test and frequency optimization. So a lot of our trips offshore, the testing intervals are dictated by regulatory. But in the cases that they're not, we historically had just defaulted to the regulatory intervals. So what we did on Perdido was to look at the testing intervals that we can get and still maintain the required risk reduction factor. So using SLM, you could take your output testing frequency and input testing frequency and see all the various permutations of it and where we can still stay above the target risk reduction factor. So on Perdido, we had 775 trips that were not required by a regulatory body, that we were defaulting to standard testing intervals, which was quarterly for SDVs and basically quarterly for most of the devices. Using that tool I showed previously, we were able to save about 500 man hours a year in testing. So most of the devices, we were able to go to yearly testing instead of quarterly and still remain above the SIL target or risk reduction factor required. Doing this saves a lot of HSE exposure, potential for nuisance trips, and just man hours in general. One of the really valuable things with SLM is the ability to bring in the process data. So in order to have an evergreen view of the strength of your safety system, You have to see how it's performing. Historically, once the HAZOP was done, once the LOPA was done, once the SIL validation was done, those are printed out and you got a PDF and you didn't revise it for another 5 years. What we do here is bring in first out demands and bypass status from the safety system and use that to compare it to the design criteria of the SIF. Like I said, so if you're having a demand on a SIL 3 every month, then that's not good. You would expect to have a demand more frequently, less frequently than that. And the bypass events, they capture when the device goes into bypass, when it comes out of bypass, and compares that to the testing interval and mean time to repair to see if there's any discrepancies. Those discrepancies would show up in KPIs for availability and demand rates. And as those change, it will flag if the performance of the SIF deteriorates to the point that it's lower than what the LOPA requires. Device performance monitoring. So when we do the SIL calculations, we have standard fault rate data that Shell provides us. Offshore in a salt environment and corrosive environment, we suspect that our failure rates are actually higher. So using SLM, we can actually have in-use statistics and compare that to what industry standard is and decide whether we want to use more conservative numbers or stay with industry standard. We have the ability to bring in supporting information. So when you're doing a HAZOP or you're evaluating a SIF, you have access to all of our documents in our document management system. You can either upload a document for reference, such as HAZOP node drawings, or you can create links to the repository that would keep the latest document up to date and available for you. In this one, you can create a custom link to send to a user for any given SIF page. So what we've been doing is if we have an MOC that impacts a safety layer, we would make the changes in SLM, validate the changes, and attach the calculations or function to the MOC for review and as part of our acceptance of the changes. And here's where we kind of bring it back to the operator training aspect. They need to know what they're really doing. So the operators can go in before they bypass the device, and when they pull up the device in SLM, it will show them all of the various trips that this device is a part of. So they can, before they put this pressure transmitter or SDV in bypass, you can see that you're not only impairing the level transmitter, you're impairing these other barriers that we're taking credit for. So, this gives them a good idea of what the trip is supposed to be protecting and what other trips it's associated with. And this is just a summary of all the things we talked about. We have a KPIs available for availability and demand frequency. We can optimize testing intervals. We can actually do quantitative risk assessment and LOPA values. We reduce the rework on the project side by changes in the design or LOPA. We generate links for users to read only so they can have access to the calculations for project information or documentation. Links to Pi, and that can go both ways. So the intention is in the future to take the availability and demand rate statistics and push those out to our cumulative risk dashboards. We have all of the device rate failure coming in, documents linked, and we can have emails configured to send us out on demand scenarios or basically any changes to the system. You can have it set up to email you. And that's it.